Hello all. Good evening.
Good evening, ma'am. Good evening,
Good
everyone.
evening.
So, have you practiced last session? Object-oriented programming. Have you understood how to create the class, how to create the object? What is the difference between class and object? What is the difference between class and an object?
In our class, we can declare the variables, mention its properties using the methods like tasks and function. Object is an instance of the class. And in system Verilog, whatever we try to do, like in the test bench, we will do it in class.
Okay. So class is the implementation of any abstract data where we put different types of functions, tasks, attributes, everything we put in the class. So whatever we are trying to access from the class, from the outside the class, we need to access through object. Okay, the class data we need to access through the object. Object is nothing but it's an instance of a class name. Okay, uh, through the instance only we need to access the data. That is what object oriented programming, everything we need to connect through a path, right? So already we have seen how to create the object and how to create the class. So this keyword, everyone understood this keyword? Did you try example?
Ma'am, explain this keyword like I not attend the previous class.
What?
Like this keyword you mentioned, no?
Mm-mm.
Can you once explain that one? Like previous class I not attend, so in video also that one not available. Like
This keyword video I already shared, second video.
okay.
Okay, no
Okay, only
problem.
watch the
I can explain. See here, actually this keyword means for every class, how we are assigning the memory to the object by creating, how we create the object by using the new method, right? In the same way, we need to create the class. Okay, that's what we call as a constructor. Whether you write the generator or driver or monitor, I already shown that example also. Say suppose it's generator class. Okay, so we have written class, name of the class, and eighth line if you see function new. New is the create method here. To create the generator we use the new method, so we write the constructor in the form of function. Okay, that's what we call as a constructor. Okay, to create every class we need to write this constructor. Even for monitor function new constructor, and for driver function new constructor, and for scoreboard function new constructor. But if you observe here internally, function new mailbox gen2 dot, we have written the mailbox in generator. But if you see in driver, we have written virtual interface and also mailbox. And if you go to monitor, same virtual interface and mailbox. And scoreboard, only mailbox. Why? Because in the test bench architecture, for generator we have only one connection, right? Generator, driver, monitor, scoreboard. For generator we will connect with the mailbox and driver to mailbox, and here also monitor to mailbox and to here, and we will connect via virtual interface and DUT. Okay, for generator, how many connections are there? Only mailbox connection. So in class constructor, we have get only one argument, mailbox. But for driver, mailbox and interface, but directly we can't connect interface, right? That's why we need to connect virtual interface. For monitor also same, mailbox connection and also virtual interface connection. And for scoreboard, only mailbox connection. So same we have written. Okay, that's what we call as a class constructor. Okay, here also created a class and packet, and within a class we have created 4 variables. One is a address 32-bit size, data 32-bit size, write, and packet type. It's a string data type. Okay, and 15th line. If you see here 15th line, we need to create the class. Okay, we need to create the class here. So creating the class function new and passing the arguments. Mostly for function we pass the arguments. For task also we pass the argument, and for function also we will pass the arguments. Okay, so here what arguments we are passing? Address, data, write, and packet type. 4 arguments. And address new is equal to address. Suppose here we are address this data we need to get from outside the module. We need to assign some data and need to pass the data to the arguments. That's what function. Okay, can you tell me what is the difference between task and function normally? Difference between task and function. How many of you know?
Function takes a very less time to execute, but task is a long running. Task takes longer time than the function to execute.
Delays are accepted in tasks. Function will not.
Okay. Any other answers?
In task we can call function, but in function we cannot call task.
Okay. First of all, task in the sense we can mention the delays like hash delays, at the rate of events, wait statements, everything we can put in the task. But in the function we cannot put delays. Remember this point, everyone. In UVM also we will use task and functions. Okay. In functions we cannot mention the delays. It doesn't contain any delays and timing control statements. Okay, and in task it doesn't return any value. It can pass the values through argument, but it don't return any value. But here whatever we are passing the arguments, it returns single value in function. Okay, and mostly task can be called using task only. Functions can be called through the function name directly. So here if you see function new is there, from outside the module through the function new we are calling here like that. And even in task, if you don't mention any input or output in out arguments, that will be fine. Okay, no need to mention the argument. 0 arguments also fine. But here it takes 0 or more argument and no output or in out. In task, we can put 0 arguments, no arguments also fine, but input, outputs, everything we can mention. But here we cannot mention input and output or in out. Only input arguments we can mention in the function. That's why if you observe here, all these are normal arguments, not inputs or outputs. Okay. And coming to task, it executes sequentially. Mostly for fork join also we write the task. If you see here environment, in environment only we will run those 4 in top level, right? See, fork join is used in the task, but fork join cannot be used in the function. Okay, because it always execute in 0 simulation time, right? We don't have any delays in the function. So that's why fork join cannot be used in the function, only in task. And also mostly tasks are used in all test benches, behavioral models, procedural, like everywhere. But in functions, we can use in RTL models mostly, and also like this to create the constructors or to assign some expressions like this, we use function. Okay, so that is the difference between task and a function. So in a function, you cannot put any delays. Okay, you need to compute a value without any timing control, and it will you require only single value written. It's written only single value. That is what the function. Okay. So here, if you see these values, these arguments, we are getting from here. Okay. Hexadecimal 10 is passing, FF1 good packet is passing. But these values we are assigning to some other variable, because here we need to print, right? So where you will assign those variables? Anyway, you need to take some extra variable and assigning here address new, for data new, write new, packet type new. We are taking new variables extra and printing here, assigning here and printing the statements. Again, another function void we have taken and printing. Okay. So again in the module we have created packet pkt equal to some new passing the arguments and calling the display statement. So how we are calling through the pkt is the object dot display. Okay, so now if you do run, we will get the output. See, address equal to 10, no, data equal to ff, write equal to 1, pkt equal to good packet. It's a string. We got the output. Okay, but taking all these values, it's a very complex, right? So the coding wise, we need to write again 4 values. If there are 100 inputs, for 100 inputs, we cannot take this again different variables, right? So for that purpose, without using this, okay, we are trying to assign with the same variable. Address equal to address, data equal to data, write equal to write, and pkt type is equal to pkt type. We are trying to assign the same variables. Okay, so then what will happen? Now run and check. See, address equal to 0, data equal to 0, write equal to 0, packet type, nothing is getting. Okay, so it is not assigning the values to the same. Okay, so compiler is not taking like this. Okay, so compiler is getting confused to which value you need to assign. That's why whenever you are accessing the same variables within the class, okay, within the class, then you need to write this dot address equal to address. That means within this class, we are trying to access the same variable, assigning the same variable data to same. Okay, so that's why we need to use this dot data, this dot write, like this. Same variable you are assigning, just you need to put this. No need to create extra variables and no need to assign to extra variables like that. Okay, now check what is the output. See here. Now we got the output. Address equal to 10, data equal to ff, write equal to 1, packet type is equal to good packet. Every example is a common. Even if you are creating the test bench in generator class, if you see two or here one argument we are passing, right? So gen2 drive, this dot gen2 drive is equal to gen2 drive, this dot gen trans equal to new. Like that we need to use. It's a common. Okay, here also this dot DRIF is a virtual interface name instance. So next to mailbox, common. Okay, in system Verilog and UVM, all concepts will be same only. Same in the sense whatever we learn here, basics, directly we put conceptual wise in same test bench. We will put all the concepts. Okay. But whenever you are learning something, try to clarify the things. Okay. Whenever you are writing the test bench, you need not to confuse, right? Why we are writing the function here, why we are taking this, everything you need not to confuse. Okay. So that's why while you are learning whatever the basic, every small topic also we are going to put in the test bench development. Okay. So that's why just be clear with every concept. If you have any doubts, you can ask. Okay. So clear this keyword?
Yes.
Okay. Now next example. Inheritance. Inheritance we already discussed, right? From main class, that means base class we can call, or parent class we can call. Okay. So from parent class we are deriving subclass, derived class or subclass. Okay. Extended class, like that. There are different names. Parent class we can also call as a super class. Okay. So whenever you are inheriting the properties of parent class to the child class, we can call it as an inheritance concept. Okay. So if you see the theory here, inheritance is the mechanism which allows a class A to inherit properties of a class B. Okay. Class A properties we are inheriting to class B. That means class B can access the data of class A. Whatever you mentioned in the class A, suppose here in the same example, we have created the packet class. Okay. So this is what the data we put into the packet, address, data, write, packet. Okay. So now if you create the subclass for this main class, how we create the subclass? Down again, you need to write class packet extends class subclass extends packet. Like that we need to write. So that's what we call as an inheritance. Now in that subclass, all this packet data can be inherited. It can access all this packet data. Okay. Child class can access the parent class properties, but parent class cannot access the child class properties. Okay. You need to remember this point. Write down that. Okay. Objects of class A, this have the access to attributes and methods of class B without the need to redefine them. The following definitions defines, say A is inherited from B. Class A to inherit properties of class B. Okay. Class A is inheriting from class B. Okay. Now B is the parent class, A is the child class. Okay. Okay. Correct. So what you can do, okay, the idea of inheritance is simple but powerful. When you want to create a new class and there is already a class that includes some of the code that you want, you can derive your new class from the existing class. Suppose there is a I2C protocol. Okay, in I2C protocol, we already have, suppose versions will be there, I2C 1.0 or 2.0, like that. Okay, in 1.0, already all test cases are available. Okay, from that, you just need to take, you just want to take the copy of that 1.0 test case. So how you can take the copy? Here you can create the another child class to the parent class. Okay, so that into the child class, whatever already available of version 1 data, that will be inherited to the child class. So directly we can use, no need to write again. Okay, like that, multiple number of protocols you are using. That time also we can use the inheritance concept where we can access the data easily. Okay. So in this case, you can reuse the fields and methods of existing class without having to write them yourself. So what can you do in a subclass? A subclass inherits all the public and protected members of its parent class. Whatever the local data or public data or protected data, everything will be written in the subclass. You can use the inherited members as is, and you can replace it, you can hide it, and also supplement them with the new members. Okay, so the inherited fields can be used directly just like any other fields. You can declare a field in the subclass with the same name as the one in the superclass. Whatever we have written in the superclass or parent class, you can write same thing in the child class. You can declare new fields in the subclass that are not in the superclass. The inherited methods can be used directly, and there you can write a new instance method in the subclass. Just go through the theory. Whatever we are discussing, same written here. So now we'll see the example how to write the program. Okay. See here. First of all, class parent. Okay, parent is the name of the class. Task printf. Written a printf task. So display, this is parent class. Within the task, it is displaying the parent class. Okay. End task, end class. Next, in the 9th line, we are creating the class syntax. You need to remember subclass. Okay, this is what class subclass, but extending from parent class. So it is inherited from parent class. Okay. In this also written another printf task. Task printf display statement. This is subclass. Okay. End class, end task, end class. End task, end class. Okay. So one parent class, one subclass. But from where we can access this parent class data and subclass data? From the outside the class. So we are creating the program main. You can create the module also, module or program, anyone. There are leftover topics are there, right? The small topics, static and casting and dynamic casting program. There are just 2 or 3 topics. We will discuss those also. No need to worry. So program, name of the program, main, initial, begin. So see here, parent is the name of the parent class. P is the object and subclass S is the object. Creating the objects, P is equal to new, S is equal to new. And P dot printf, S dot printf. So here we are calling the task, parent class task through P. P dot printf, S dot printf. Okay. So what is the output now? What is the output?
Printing this display.
It's the statements.
This is parent class. Next.
This is subclass also.
This is subclass. Okay, just run and check. So see here, this is parent class and this is subclass. Okay, so the properties, class properties, parent property is inherited to the child class and created one object for parent and created one object for child subclass and calling the printf task and the subclass task. Okay, so this is how we do the basic programming, very basic example. Okay, next example, super keyword. What is mean by super? Super keyword is nothing but where we call the parent class data. That's what we call as a super. Suppose here within the task printf, we are using super dot printf. That means we are calling the printf task which is available in the parent class. Okay, by using super.printf, we are calling the printf task. So just run and see what is the output. What will be the output? What is the output?
It will
No
print
idea.
students. This is parent class.
Parent class and this is
parent class twice. Maybe.
parent class twice.
Yes.
And then this is subclass.
Okay. So this is parent class first and second and subclass. Okay. So without printing twice, because here we have created parent P and also creating and also calling the printf task. Without creating the printf task, you can access the parent class properties from the child class. Okay. So by using the super keyword, run and check. See here, this is parent class, this is subclass. By using super keyword, we can access. Okay, clear everyone? If I write super keyword 2 times like this, what will be the output?
First, it will be this is parent class. And again, this is parent class, this is subclass, and this is parent class.
This is parent class, this is subclass, and this is parent class. Okay. So, as I told that parent class, okay, that thing we will see next example. You'll understand. Next example is only method. Okay, same whatever we did here, same is only method. Creating the subclass s is equal to new s dot printf. Suppose I'm not using the super dot printf method. I'm just commenting here and run. Then only child class data will be printed. Only this is subclass is printing. Okay. And suppose okay, anyway, you will get in next polymorphism concept. Is first method super.printf same is also method same, both are same, just using super.printf method. Okay, so we'll see another example for inheritance. Everyone clear what is mean by inheritance? How the parent class data is assigning to the child class and how the properties are accessing? Clear? Any doubts still here? And also yesterday I have shared the object-oriented programming assignment. Have you seen that? How are the questions?
Yeah, I've seen that.
Yeah, even I did see the questions.
What about Kalyan, Manoj? Muralidhar, Sunny, Rakshita, Aditi, and Shweta. Are you practicing the assignments?
Yes.
Yes, ma'am.
Are you
Yes,
not
ma'am.
getting
Yes, ma'am.
doubts? You are not
Yes,
asking.
ma'am. We have doubts.
I have doubt, Prashanti.
Okay. We will discuss at the end of the session. Fine. So, inheritance example. See here. Fourth line. Class, base class. Base class is created and protected. Okay. Okay, let it be. Protected is in encapsulation actually. So protected int id. Okay. Function new int id is equal to 0 initially. And this dot id is equal to id and function. This is how we create the class constructor and virtual function void. Is this inheritance example? In the next examples, you will get why do we use the virtual function, virtual task, or virtual class. Okay. So function void display here displaying base class ID. And next to derived class, 17th line, taking the subclass, we also call as a derived class extending from the base class. So this is the syntax. Class, derived class, extends base class. String name, function new, passing the ID and also string name. ID is from base class. String name is created in the child class. Okay. So super dot new of ID. Whatever the here function is that this function calling in the child class super dot ID is equal new dot new of ID. This dot name is equal to name exam end function and creating the class constructor display statement, sorry. And in the program, TV initial begin base class 100 new equal to 100. So passing ID value as a 100 and base object creating the calling the display here, this display function and derived class object derived obj new to 100 and passing the string name here and calling the display statement. Okay, this is how we write the inheritance, only inheritance. Okay, so we will discuss this protected and virtual later. This is what inheritance means. Okay, now run and check the output. Error, what is the error? Warning, explicit lifetime definition is required for local variable. Okay, 36 line and here. Can you tell me how can we avoid this error? What are the changes we need to do? See the error. Just see the error. I am sharing the code. Copy the code and check the output in your EDA playground. Why it is getting the error. Okay, I will come in 5 minutes. Just check why it is getting the error.